If you stand outside on a clear night and gaze up at the star-filled sky, it's hard to imagine that out in that dark expanse, there are wanderers drifting for billions of years. They don't belong to our solar system, never bound by the sun's gravity, and most will never come anywhere near us. But every once in a while, incredibly rarely, one of these travelers crosses the invisible border into our cosmic neighborhood, leaving only the briefest trace of its presence before vanishing forever. In all of modern astronomical history, this has happened only twice. The first time was in 2017, when Oumuamua streaked past, sparking endless debates and unanswered questions. The second was in 2019, when Comet Borisov blazed a brilliant trail, carrying ice from a place we had never seen. After that, many scientists thought we might wait decades before witnessing such a spectacle again. But the universe has its own way of surprising us. On the night of July 1st this year, while the Atlas telescope in Chile was performing its routine sweep of the skies, scanning for objects that might pose a threat to Earth, a faint, fast-moving point of light appeared. It was coming from the direction of the Sagittarius constellation, a crowded region of the galaxy usually too bright for many surveys to examine closely. Right away, astronomers knew this was no ordinary object. Its orbit was steeply inclined, its speed far greater than that of any asteroid or comet native to the solar system. Analysis confirmed the stunning truth. This was 3I Atlas, the third interstellar object ever detected. But being third on that short list is just the beginning of the story. 3I Atlas may be the fastest, largest, and brightest interstellar visitor we've ever seen. It's a traveler from beyond the sun's reach, arriving here after an almost unimaginable journey, a journey measured not in miles or years, but in billions of years and across the gulfs between stars. And behind that faint glow captured by the telescope that night is a story waiting to be told. One that will carry us into a voyage through distances and timescales that stretch the limits of our imagination. Hello and welcome. I'm Orion, coming to you from Infinite Universe NTH. Once the discovery was confirmed, 3I Atlas instantly became the star of the astronomical community, not just because of how rare it is, but because its numbers are almost unbelievable. Orbital calculations revealed that it isn't bound to the sun's gravity at all. Instead of tracing an ellipse like planets or homegrown comets, 3I Atlas follows a hyperbolic path with an eccentricity of about 6, an extreme value that screams one thing. This is a one-time visitor. Once it's gone forever. Even if we wanted to send a spacecraft after it, the sheer speed makes that a fantasy with our current technology. To put that speed into perspective, at closest approach, it's moving at 58 kilometers per second. Fast enough to cross 580 football fields in the time it takes your heart to beat once. If it started from the moon, it would reach Earth in about 7 seconds. That's not just the fastest interstellar comet we've ever seen. It leaves the previous record holders, Oumuamua at 26 km/s and Borisov at 32 km/s, far behind in cosmic dust. Its size is just as jaw-dropping. Based on its brightness and reflectivity, astronomers estimate its nucleus to be about 10 kilometers across, roughly 6 miles. That's 10 times larger than Oumuamua and several times larger than Borisov. A massive object, moving this fast, from outside the solar system, that combination alone makes it a once-in-a-lifetime target for study. But 3I Atlas isn't just a cold, lifeless rock. Telescopes around the world have spotted a thin coma, a haze of dust and gas produced when ice sublimates under the sun's warmth. Its tail, while subtler than Borisov's, stretches more than 25,000 kilometers, about twice the width of the continental United States. That means even after what could be billions of years drifting through interstellar space, it still carries enough volatile material to put on a show when it gets close to a star. Its color is also telling. The comet's surface has a deep reddish hue, darker than the sun, and even more intense than the D-type asteroids that live in the outer asteroid belt. This redness is likely the result of eons of exposure to cosmic radiation, slowly sunburning the surface over unimaginable spans of time. You could think of 3I Atlas as an ancient traveler, its skin weathered and darkened by countless journeys through the harsh deserts between the stars. According to its trajectory, on October 30th this year, it will reach perihelion, its closest point to the Sun, at about 1.4 astronomical units inside the orbit of Mars. That's when it's expected to brighten and possibly become more active, offering the best opportunity for observations. Its closest pass to Earth will be at 1.6 AU, more than 600 times the distance to the Moon. So despite its size and speed, we're in no danger. Perhaps the most mind-bending detail is its estimated age. By correlating the velocity of stellar objects with the age of their systems, astronomers estimate that 3I Atlas could be between 3 and 11 billion years old. That means it formed either in the very early days of our galaxy, or perhaps even before the Sun existed. Over that time, it may have crossed countless star systems, witnessed the deaths of ancient suns, and skirted worlds we can only dream of. When we look at 3I Atlas, we're not just seeing a comet. We're looking at a living fragment of cosmic history, a witness to events that happened before our planet was born. And that's why astronomers all over the world are tracking its every move, hoping to catch even a glimpse of the secrets it has carried across the galaxy for billions of years. The real shockwave in the astronomy world came when the numbers started stacking up side by side. This wasn't just another interstellar visitor to add to a short list. 3I Atlas was breaking records in every category that matters: speed, size, and brightness. We had never seen all three extremes converge in one object before. For scientists, it was like finding a fossil that not only predates human history, but also comes from an entirely different continent, one that's long vanished beneath the ocean. As its discovery was announced, online astronomy forums lit up. Professionals were already reserving precious telescope time, and amateur astronomers were racing to capture it with backyard setups. High school students, retirees, deep sky photographers, everyone wanted a piece of this cosmic guest. The astronomer's telegram, normally a trickle of specialized reports, turned into a daily bulletin board of new measurements, sharper images, and bold predictions. You could almost feel the community leaning in, collectively holding its breath. And then came the detail no one expected. Its light curve was almost perfectly flat. Over a rotation period of about 29 hours, the comet's brightness varied by just 0.2 magnitudes. That might sound technical, but here's what it means. Unlike Oumuamua, which flashed and dimmed wildly as it tumbled, 3I Atlas seems to have a far more uniform shape and reflectivity. It's not elongated like a space cigar. It's probably closer to a classic rounded cometary body. That makes it an outlier among outliers. Compared to Borisov, which put on a spectacular show with a tail stretching 140,000 kilometers and intense outgassing even when it was 4.5 AU from the Sun, 3I Atlas is relatively restrained. Its coma is modest. Its tail, while impressive, is nowhere near Borisov's sprawling plume. At first glance, you might think that makes it less exciting. But here's the twist. Restraint can be just as revealing as drama. If a comet can travel billions of years through interstellar space, collide with micrometeoroids, endure radiation storms, and still arrive with such a massive, intact nucleus, that tells us something extraordinary about its internal structure and history. It's not just surviving, it's thriving out there. Some scientists have speculated that its relatively mild activity might hint at a crust or insulating layer that shields volatile ices beneath the surface. If that's true, 3I Atlas could be hiding a reservoir of pristine material that hasn't been exposed since the dawn of its home system. Imagine if we could study that. We'd be peering directly into the chemistry of another solar system, preserved like a time capsule. The speed, the size, the stability. It all points to a traveler that's not just passing through, but carrying with it billions of years of untouched history. And while the public fascination focuses on its bright appearance and record-breaking velocity, for scientists, the real thrill is the possibility that 3I Atlas might hold secrets no other object can offer. In moments like this, you realize that the most astonishing thing isn't that we found it, it's that it found us. Out of the endless emptiness between the stars, through sheer cosmic chance, it's here, now, in our skies. And if we're lucky, it will leave behind more than data. It will leave behind a reminder that the universe still knows how to surprise us, even when we think we've seen it all. The arrival of 3I Atlas didn't just send ripples through the scientific community. It set off a wave that reached far beyond observatories and academic journals. From university research labs to small-town astronomy clubs, from backyard telescopes in suburban driveways to live streams watched by tens of thousands, this comet has become a shared moment for anyone who's ever looked up at the night sky and wondered what might be out there. In professional circles, the scramble was immediate. Observatories in Hawaii, Chile, South Africa, and across Europe were scheduling time on their largest instruments, knowing this was a fleeting chance to capture every detail before the comet disappeared forever. The Las Cambri Observatory network, with its telescopes spread across the globe, began coordinated campaigns to track its brightness, rotation, and activity. Teams from different continents were trading data almost in real time, each new observation adding another piece to the puzzle. But what made 3I Atlas truly special was how quickly it spilled out of purely scientific channels and into the public's imagination. NASA's JPL Horizons tool gave anyone with an internet connection the ability to track its exact position in the sky. Suddenly, teachers were pulling it up in classrooms, showing students how to follow an object that had traveled billions of years to reach us. Amateur astronomers were sharing their own images online, some of them capturing the faint coma and tail with nothing more than a well-tuned camera and a clear night. Even casual sky watchers got swept up in the story. Astronomy forums buzzed with advice: when and where to look, what equipment you'd need, how to photograph it. Social media turned into a gallery of glowing green dots and streaks against starry backdrops, each one accompanied by a caption filled with awe. This comet is older than Earth itself. The global nature of the event gave it an almost unifying quality. In an era when so much news divides us, here was something pure, a visitor from beyond the sun's reach, visible to anyone on the planet willing to step outside and look up. Whether you were an astrophysicist studying its spectral signature or a child seeing your first comet through binoculars, you were part of the same moment. For scientists, these public contributions weren't just feel-good extras. They were valuable. Distributed observations helped refine measurements of its tail length, activity levels, and even rotation period. A report from an amateur astronomer in Spain led to a revised estimate of the tail's true extent, over 25,000 kilometers. In that sense, 3I Atlas became a rare example of modern science at its best. Professionals and enthusiasts scattered across time zones, building a complete picture together. The comet's presence reminded us that while space can feel remote and inaccessible, some of its most remarkable stories can be followed from your own backyard. And in sharing those stories, we become more than just observers. we become participants in a global moment, one that will vanish as quickly as it arrived, but will be remembered by anyone who took the time to look. By late October, 3I Atlas will sweep past the Sun at its closest point, just inside the orbit of Mars. From there, it will slip behind the Sun's glare, vanish from our view, and briefly reappear in early December before it accelerates back into the darkness between the stars, a place from which it may never return. For us, the clock is ticking. Every observation, every image, every data point we collect is a race against time. Encounters like this are not just rare, they're fleeting. Out of all the billions of comets and asteroids in the galaxy, only 3 interstellar visitors have been spotted in recorded history. Statistically speaking, we might have to wait decades for another. That knowledge gives a strange weight to every night 3I Atlas is visible. You're not just looking at an object in the sky. You're looking at an opportunity that will be gone in the blink of a cosmic eye. But perhaps the deeper message is that the universe is not as distant from us as it sometimes feels. 3I Atlas has spent anywhere from 3 to 11 billion years drifting through the Milky Way. In that time, it may have passed by dozens of suns, skirted alien planets, and crossed interstellar clouds where new stars were being born. And yet, through an unimaginable sequence of gravitational nudges and chance alignments, it found its way here, into our neighborhood, at a moment when we had both the technology and the curiosity to notice. For scientists, it is a once-in-a-career opportunity to probe the untouched chemistry of another star system, to compare its traits with Borisov and Oumuamua, and to refine our estimates of just how many wanderers like it are out there. For the rest of us, it is a reminder that we live in an open system, that our solar system is not a sealed-off island, but a port that travelers occasionally enter before continuing on their way. There's a poetic symmetry in that. Humanity, too, is a traveling species. We've crossed oceans, continents, and now space itself in our search for knowledge and connection. In 3I Atlas, we might recognize a kind of kinship, another voyager, carrying the marks of its journey, moving ever forward. When it finally fades into the deep, empty black, the data we've collected will remain. But more importantly, so will the memory of what it felt like to stand under a night sky and know that, for a brief moment, we shared our corner of the galaxy with something ancient, fast, and impossibly far from home. The next time you look up at the stars, remember that the space between them isn't empty. It's alive with travelers. And somewhere out there, perhaps even now, the next one is already on its way. Thank you for joining me on this journey. I'm Orion, and this is Infinite Universe NTH. If this journey made you think, feel, or simply wonder, please consider subscribing to support the channel. There are more questions waiting, and together, we'll keep searching.